Do you want a web browser made for the internet of today? We created technology that automatically blocks trackers, annoying ads, and shields everything. You can expect browser speeds up to 7 times faster on mobile. Try Brave. It's faster, safer, and ad-free.
On today's Visual Studio Toolbox, we're going to continue looking at unit testing tools, and we're going to explain xUnit. Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green. Joining me is Phil Japikse. Hey, Phil.
Hey, Robert.
This is part 2 of our multi-part series on unit testing.
It is.
We covered sort of an introduction to unit testing and test-driven development in the previous episode. Today, we're going to do a deep dive on xUnit.
Yeah, we want to make sure that, after all, this is Visual Studio Toolbox,
Yes.
that we cover the tools so that you aren't hindered by by the tooling.
Right.
Easy for me to say. So let's talk about xUnit.
So what is xUnit? Give us a little history. Where do you get it? How do you add it to your projects?
Sure.
Then we'll talk about how to use it.
So there's a couple ways to add it. The easiest way is go out to NuGet and search for xUnit.
And it is a testing framework.
It is a testing framework, and then it also has a runner built into it. Here, the xUnit.runner.visual studio package enables it to tie into the Visual Studio runner.
Okay.
It also works with ReSharper and many other libraries. If you go out to NuGet, you can get add-ins for TeamCity, for VSTS, for MS Build, for everything else. So you can run it from a build process as well.
So works inside Visual Studio, works in the Test Explorer. Does it work with live unit testing?
It does work with live unit testing as well.
Okay. Good.
And the other way, real quick, if I say add new project, this is how important it is to Microsoft. I can go .NET Core, xUnit test project .NET Core. So it sets it up for you.
Okay.
You'll just want to update the packages because the template, of course, is,
Sure.
as soon as the template ships, it's out of date.
Right.
Right, with all templates. So then you would just right-click and say update NuGet packages.
Okay.
So xUnit is what I typically use. It was one of the first ones to be compatible with .NET Core. It's not to say that the other testing frameworks are bad. It's just the one I prefer.
Sure.
NUnit works. MBUnit works. MS Test works. I have some issues with how it works.
Fair enough.
And we're going to cover a couple of those here early on, the differences. So we saw a quick demo in the last episode of xUnit. Again, I want to go into great detail. There's some name changes that might throw you for a little bit of a loop.
Changes from...
maybe 30 seconds from NUnit and MBUnit.
Okay.
So
if you were using NUnit and MBUnit, things are named differently in xUnit. If you are new to all of these...
then it's not a name change.
Right.
Because it's brand new.
Exactly. All right.
But in the prior frameworks, we would call a test a test. Seems quite simple. And then a data-driven or scenario-driven test, a row test, typically. It's just a fact now. That's the name. It is a fact that it's a fact. They just changed the name to fact. In theory is then a data-driven test. So that's something that might take you 30 seconds to get used to if you're coming from an existing framework, if it's brand new. Hey, you know what? We are stating that this is a fact, that this assertion is true, and then we have a theory that all of these assertions and scenarios will be true.
Okay.
So we can also ignore tests. Now, this is considered an anti-pattern in the testing world to ignore a unit test, because if you have a broken unit test, you should fix the code or fix the test itself, because tests can go stale. Need to get fixed. But you know what? Sometimes reality happens, and shipping's a feature, and your build's not working because this test is failing. You can't figure it out. Whatever the reason being, you can ignore it so it's no longer run, but then I would strongly recommend you do something like add a to-do, or conversely, you can also add the hack. And then that will show up in your task list to go fix. So let's talk about theories, because I think that's one of the most powerful parts of xUnit is the ability to use the exact same code, the arrange, the assert, and the arrange action and assert. It's easy for me to say after talking all day. And have multiple scenarios tested without having to keep copying code. We saw an example of the inline data, and that's where we're passing data directly from the inline data attribute into these parameters on the unit test method itself. That's pretty straightforward, but let's talk about some additional powerful things that we can do. And we can say, hey, there is a member that I have access to because it's either in the class or within the referential patterns, where I can return data. And so this test data method is returning an IEnumerable of object. Each of these objects then get mapped to the parameters of the test itself.
Okay.
Now this is important if you've got something that's more complicated than adding in inline data. For example, when I was working in insurance, we had these actuary tables where we had all these parameters we were throwing in. I didn't want to sit there and type every single line of Excel in the samples and the acceptance criteria into inline data, but I could write a method that would then read the Excel file and do a yield return to return those values and map it.
Okay.
And if the accountant added more data, then I just swap out the Excel file. I don't have to change my code.
Okay.
So that's extremely powerful. And the third option is we can have a class that implements IEnumerable of object and do it that way. To be honest, I haven't used this in real life, but I just felt important to show our viewers that it's able. But the two main methods I use for simple tests where I have a few cases or a few parameters, I use inline data. And then it's easy enough to add another scenario by simply copying that. And let's say this is 100 and -3, and this would equal 97.
Right.
And this for more complicated data.
Okay.
Let's talk about test running. For most people, you'll never have to change this. xUnit and its runners run their tests in parallel. It's a performance improvement. You can't really find a single core machine these days anyway, right? So you might as well take advantage of that. The way it decides what's parallel and what's serial is based on the class level.
Okay.
So any tests inside a single class will all run serial, but tests across classes will run parallel.
Okay.
Now, if this is a problem for you, and I can't think of a situation where it would be a problem, but if it is a problem for you, you can disable that very simply by creating what's called a test collection. And what you do is you attribute your two classes with the collection attribute and the string name. Unfortunately, it is a magic string. But any test classes or fixtures that share the same name of the collection attribute will combine all those tests to run them serial.
Okay.
The other big change between the prior frameworks and xUnit is how we handle exceptions. In NUnit, there is an expected exception attribute that we could decorate the tests with. And the problem with that, and this isn't allowed anymore, but let's just pretend it was. Right? I could do, if I could type expected exception right here. And it's not in there anymore. As we see, this is something different. And then we would put an exception type in there. Well, the problem with that is what would happen if your arrange through that exception never calls into the system under test. Sorry, as I use my exceptionally large coffee cup to try and calm the cough. Then the test would be marked as passing because the exception did get thrown.
Right.
But we never actually exercised the system under test.
Right.
So that pattern has been decided to be an anti-pattern. And I don't want to say that the folks who wrote those original frameworks were wrong. It's just we've learned different ways of doing testing, and we continuously improve and do better. So what we do now is we assert that an operation throws an exception. So I have the system under test. Now this is just hard-coded to throw an error. But if I want to say calculator.add int.maxValue, comma, null, and the null should throw an exception, then I can trap it here, and I know that it's getting thrown at the invocation of the system under test, and not somewhere in the test itself. It returns the exception for us, so then we can start looking at what's the message. If it's an argument null exception, then we can look at what argument was missing, and we can do all kinds of assertions on that exception. There's another way to do it that's a little more fluent. This is the arrange act assert syntax more closely, where we say we're going to record an exception. Honestly, they both do the exact same thing. Dealer's choice, whichever one you want to use. But what's important to note is that we want to check for the exception at the invocation of the system under test. All right, somebody might be thinking, well, what about test setup and test teardown? So in the other frameworks, we've got this ability to do a fixture setup that's going to execute before any other execute once before any other test, or a test setup where we want to execute something before every test. So instead of marking methods with the setup and teardown attributes as we used to do, we now use the constructor dispose pattern. So if you make your test fixture disposable, can you get that?
No.
Okay.
I'm busy.
Robert's phone just rang, so yeah, hey, we'll wait. You guys wait too, right? So I mark it as disposable. The constructor for the test will run, for the class, will run before every test. This is a test setup, not a fixture setup. And then the dispose will run after every test. So for example, if you are creating something, I do a lot of testing around Entity Framework Core. I'm not testing Entity Framework Core, but I'm testing my data access layer. They're not technically unit tests. They're going to integration tests, whatever. Let's just call them tests, right? And get away from the academic debate. I want to have a brand new context before every test. I don't want to have anything in change tracker. I don't want to have any of that baggage with me. So in my constructor, I create a new context. In my dispose, I dispose of the context. And so that will happen, again, before and after every test. We can also set something up as what's called a class fixture. And when we use a class fixture, what happens is we get the equivalent of the fixture setup and fixture teardown. I'm going to run this code one time before all my tests are executed. I'm going to run this code one time after all my tests are executed. It's not a generally accepted pattern among most people anymore, but it's there if you need it. The test setup and teardown is really what we're driving people to use more and more, as opposed to having this entire set of tests depending on a certain setup and teardown. And the reason being is we want our tests to be atomic. We want every test to be individual, not depend on other tests and things like that. And we tend to start adding things into the tests that make them less atomic if we have this whole fixture setup and teardown. The last thing I want to cover is capturing output. Now, if you're running in, for example, ASP.NET Core, and you're using Kestrel, all the output is done to the command window. But typically, we're writing our unit tests in a class library. And we don't want to go through a whole bunch of hurdle of adding and logging and things like that necessarily. But we want to have output in there. Well, that's actually very, very simple in that we can, in our test, add in the iTest output helper. And then when we say output.writeLine, it's going to output to all of the standard out. right? Which by default is the console.
Right.
So I can add additional. So if you're trying to figure out what's going on, there are times when you're debugging a test and it behaves differently than when you're running it full on. And you want to be able to do the old, you're old school like me, right? When we were doing classic ASP and alert, made it here. Right. Alert, made it here. Yeah. Alert, made it here, right? So this allows you to do that if you're in a situation where straight up debugging isn't working for you.
Got it.
So that's pretty much the power of xUnit. I know I glossed over some of the things, but the most important thing I want people to take away from this is it works in core, works in full .NET Framework. Mm-hmm. It's free. It works with pretty much any build server that you have. I haven't yet hit a situation where it's not supported by a build server. You get the road test capability or the scenario-based testing capability. And we try not to call it data-driven testing because then people think, well, you're using a database. Mm. Yeah, even though it's inline data. So we call it scenario-based.
Okay.
And then you can control the parallelism. And then we trap exceptions at invocation as opposed to anywhere in there.
Cool.
So any questions about xUnit? There's a ton more in xUnit, but these are the features I think people are going to use most often.
Okay, so again, this is a test framework. So you've shown us the scaffolding, if you will. And then the tests you write are typically going to be independent of the framework? To what extent? Yeah, that's a good question. To what extent do the actual tests you write depend on the framework you're using?
What the dependency is mostly in the asserts.
Okay.
So, for example, in xUnit, it's assert.equal. Mm-hmm. In NUnit, it was, if my memory serves, assert.isEqual, right? Or are equal. I don't remember the exact. Right. So some of the syntax. So this is very dependent. All these asserts come from xUnit.
Right.
They're built into it. So that's dependent on the framework, right? Mm-hmm. Some of the syntax things. But this code here, my arrange and my act, totally independent of the framework.
Right.
Right? We are dependent on the framework when we're looking at exceptions. So when we get into here, right, this syntax here on line 22 and this syntax on line 30, also dependent on the framework.
Right. Okay.
But the actual invocation of your system under test, the creation of your MOQs, which we're going to cover, I believe, in the next episode, that is all independent of xUnit, NUnit, MBUnit, MS test.
Right. Cool.
So, any other questions about xUnit?
Nope.
All right.
All right. So that was a great overview of xUnit testing framework. And in our next episode, we're going to cover
MOQ.
MOQ. Awesome. See you then.
Thanks for watching.